Hello and welcome to AUTOINFORM Online Magazine How-To Workshop. My name is Frank Massey, and in this issue I'd like to look at pressure testing. Now, what I'd also like to bring into focus is the way in which we've evolved some of our tools so that they become multitasking tools. So I'd like to introduce the basic tools we're going to use in this presentation, and we're actually going to test a radiator cooling system. The first tool is one we've had for many years, and it's to evaluate the efficiency of withstanding pressure inside an engine, cylinder leakage testing. The principle is quite straightforward. You apply compressed air supply, you meter that compressed air into an enclosed cylinder, in other words all valves closed, with a static engine, so you have to lock the engine to prevent the compressed air from pushing the piston down the bore, and then you set a theoretical test pressure. You then check the leakage rate. So once you open the valve, any leakage through the engine is then recorded as a percentage on the gauge. The gauge doesn't actually record pressure, but areas of performance. So green is acceptable, orange questionable, and red a severe leak. We actually had a situation where we wanted to apply real-time pressure. In this case it was to an intercooler on a vehicle, a turbocharged vehicle, and we wanted to apply real-time pressure to be absolutely sure that the hoses and the connectivity to the intercooler and the air charge circuit was robust enough to withstand maximum boost. And we've tried a number of methods in the past, and we started to adapt this tool to provide a controlled amount of air pressure. The first problem, of course, was this gauge doesn't record pressure. It's important that if you're applying pressure to a circuit that you mimic the exact value. For example, a turbo would normally provide, say, a maximum, say, 1.2 bar boost above atmosphere, and the radiator system around 1 bar. We needed to know that value very accurately. So we then introduced the use of our fuel priming gauge. Now, this obviously was developed to measure hydraulic pressure in both diesel and petrol systems, both negative pressure and positive pressure up to 10 bar. We had some time ago standardized all of our fittings, so that made it quite easy to be able to adapt the cylinder leakage test tool with the gauge and use them both together to apply a controlled pressure, very accurate controlled pressure, to any component, whether it be an intercooler circuit, a radiator system. So I'd like to show you pressure testing or proof testing on the cooling system, where at times it can be very difficult to find a leak. So generally speaking, the pressure within a radiator system is around 1 bar. It's registered on the pressure cap, so if you're not sure, check it, and we can then apply a proof pressure. So it's my intention to put 2 bar into this particular vehicle and check for leakage. We're using the gauge to measure the pressure, but the leakage tester to prove any a leak across the circuit or indeed through a hose. So that's the tools. We have a number of adapters. Once again, we've made various adapters up, male to male, female to male, extension leads, so that these tools can be literally anywhere, including actually in the vehicle on the front seat. So it's completely flexible in terms of how we can adapt this system to a vehicle. So let's begin by connecting this up. And I've already predetermined which adapter to use for this particular application. So we simply remove the radiator cap, insert the relevant adapter, we need to connect the compressed air supply to the cylinder leakage tool. We need to connect the gauge in the circuit so we can monitor accurately the pressure. So we have a leak detection device and a pressure measurement device, and we need to be absolutely sure that the pressure we apply is not excessive, because potentially this test carried out badly will obviously severely damage the cooling system, because we can exceed the maximum pressure. That's now connected. I think you'll agree that's fairly straightforward, robust connections, all self-sealing in actual fact. We're not putting fluid through this, it's air pressure. I'm now going to open the valve and allow air, and you can see now that the gauge, the percentage performance leakage, as an indication, but more importantly we can now measure pressure. This system, it says, around 1 bar above atmosphere working pressure. We're at 1 bar now. It is my intention to go to 2 bar to create a proof test. Very controlled test, and we can now literally, and if you feel the hoses, they are considerably pressurized with the water, the coolant, and now it's simply a case of observing any leakage. We could of course apply a UV dye into the coolant with the use of a UV lamp, then inspect the hoses. Bear in mind that some leaks only occur when the engine is actually running. In other words, if it's a water pump seal perhaps that's leaking, then it may be necessary to run the engine, and it may be necessary to run the engine up to temperature. Some leaks are temperature dependent. But this particular test demonstrates how quickly and easily cooling systems can be pressurized to a safe pressure, much quicker than some of the hand pump devices which are available, under more controlled conditions, and we can then conduct a leakage test. We also, as I suggested earlier, have used this device with intercooler circuits. Now clearly, with intercooler circuit, we'll have to build or design some means of blanking off each end of the circuit we're going to test, but in most cases that's not difficult to achieve, and then once again we can apply a controlled pressure. One of the benefits of using this is that we're not relying on the turbo. We can do a static test, make observation much more easily in the workshop without the need to actually drive the vehicle, or even use, it's very difficult to get a turbo to come on full boost statically. Even if we use a rolling road, a great deal of noise, a great deal of difficulty in observing where air leaks may actually occur. We've mentioned in other issues smoke detection, and I still use that very much, still recommend that very much, but this is just another option, another tool, another option that you have to be able to conduct genuine load testing on different systems on the vehicle. And really that is just about as effective and efficient this choice of tools has been. So we've taken a fairly dated tool, if you like, a tool which hasn't been used too much in the past. We don't do an awful lot of internal engine development, but we've adapted that tool with same fittings as we use on fuel systems, and it's now become a very, very much used and a very efficient means of diagnostic support of genuine load testing. So I hope you found this demonstration both speedy, efficient as we have, and I look forward to seeing you in the next edition of AUTOINFORM Online Magazine.